Hi. Neural cells and neural functions is something that we can't understand except on the level of a single cell. And it cannot be understood without the understanding of electrophysiology. So the ions are moving. And what kind of ions we have in the plasma or cytoplasm? Let's see. First of all, we have potassium, +1. Then we have calcium, minor component, maybe 2 millimole per liter in plasma, etc. And then we have chloride, very huge amount of chloride in the plasma, as well as we have sodium. So the sodium and chloride are the main components in the plasma, potassium and chloride the main components inside the cell. And calcium, well, that's a very small amount, but it's also very important for regulating the release of neurotransmitters, etc. So not in the action potentials, let's remove it. Also the chloride, it's important for some things, but it's so mysterious, so let's drop it away. So now we have only two. One outside the cell, one mainly inside the cell. So sodium wants to go inside, potassium wants to go outside. And for this, we have different pathways in the cell membrane. We have sodium channel and we have potassium channel. And when the channel is open, the ions can flow through the channel either inside the cell or outside the cell, depending on the electrochemical gradient. And the idea is that they are not all the time open. There are gates, the doors, that are closed. And both these in the axon are voltage dependent. So membrane voltage is affecting on them, because in both these there are some charges. They lay there on the membrane, cell membrane, and depending on whether positive voltage is outside or inside, that will affect that, okay, these charges are either moving out or in. They are not actually much moving at all because they are glued there, but that will change the structure of the channel and open the activation gate. So when the membrane is depolarized, it will open the activation gate, for example, for sodium, and then that allows sodium to flow inside the cell and depolarize the membrane and affect on the membrane potential that will then be the same as the equilibrium of sodium. But the sodium channel contains also an activation gate. So at the same time, when the activation gate, this door is opened because of the voltage change, and the sodium is flowing inside the cell, it will also close this door. And therefore, for only 1 millisecond, both gates are opened and the sodium is allowed to go inside the cell. And these doors must be reopened or reclosed before this channel can work again. And therefore, it's only working for 1 millisecond, and then it has to go for negative voltages before the sodium channel can operate again. In potassium channel, there is also activation gate. That is opened because of the depolarization. This process of opening it is a little bit slower, and therefore sodium is first, potassium is second. And now the potassium is flowing out from the cell, and that will repolarize the membrane. But there is no inactivation gate. So as long as the membrane will be depolarized, this door is opened and there is a potassium flux that will put the membrane potential back to resting membrane potential. And because there is no inactivation gate, so the potassium, it will now repolarize the membrane. And then, okay, to to become a new action potential, this door must be also closed. So this activation goes. And that happens only in negative voltages. And therefore, action potentials can't start immediately. There must be also always some short refractory period. So close this door, open the inactivation gate of sodium channel, and etc.